if you need to look back at it, this is the stuff that you can say, oh, I get what's going to be happening here. I see how we're going to be doing. So what we're talking about today, the problem is that right now all I see is a big screen that looks like snow because it's just a screen full of white. So give me just a second. Today, what we're going to be talking about is sort of the difference between expressions. Yeah, I knew that was going to be the case. It looked like it was going to be a little bit blurry. Hang on, so I can get it to focus up. That's fine. All right, so expressions versus equations. And today's date is the 5th. All right, so here's what we're going to do. We spent the better part of the first unit talking about simplifying expressions. So you guys have a lot of experience with that. What we're going to do today is use what we know about that to talk about how an equation works and what we have to do with it. Now, y'all have done stuff with equations. You wouldn't have made it to high school without some experience in equations. So I'm not assuming you don't know that, but I know that I've taught this enough that most of the time, the way we build this stuff up, it doesn't look like this a lot of times. And so I just want to make sure you understand what we're doing. And so that's kind of where we're at. And so what we spent a lot of time doing in the first unit with expressions is we were evaluating. So we did evaluating expressions, and this is going to be just kind of a little bit of review of what we've done before. And I'm just going to go through a couple examples to make sure we sort of remember this. If you didn't remember this, this is something to look back and go, oh, yeah, I remember this. This is cool. Or this is where you write me in the chat and say, I don't remember this at all. What are you talking about? And so let me start off with a first example and say what they'll do is they'll give you an expression, which is basically just variables and numbers and exponents without an equal sign. So if I give you 3x squared plus 1, for instance, and I'm going to tell you with that, that's our expression. And I'm going to want you to evaluate that for x equals -4, okay? So when we're talking about that, what I'm saying to you here is I'm giving you a value of x that you are going to plug in this expression and find out what the solution is. So anytime I say evaluate, it basically means plug in. The words that we use for that in math is substitution, but essentially what you're doing is taking this expression, wherever there's an x, I'm putting a set of parentheses because that's where I'm going to be plugging that guy in, and then everything else is around the outside, so 3 parentheses squared plus 1. And what do I put in that parentheses again, guys? What goes in here? You guys type it in the chat, that's fine. Yeah, the x value or -4, that's right. And so when they tell you what x equals, that's what you put in for the x. So you've got the information about this. Now, this kind of is an equation. I have an equal sign here. It tells you what x equals, and we're using that to evaluate it. So right now I go through and get the values for this. And we got to use our order of operations stuff to figure it out. So we do exponents first. And I can tell you -4 raised to the second power is -4 times -4, which, Uzziah, you're right, is +16. So now, first simplification tells me that's 16. The other stuff I write around the outside of it, 3 times 16 plus 1. Now, if I do that next step, then we do 3 times 16. 3 times 16, that comes before addition. 3 times 16 is equal to 48. We still got this plus 1. So at the end of this, our final answer for this problem is going to be that we get 49, because that's what 48 plus 1 is. So to evaluate this expression, when we plug in x equals -4, that is the value that gives us 49 as a result. Okay, now again, this was all the first chapter. I know this is review, but the reason I wanted to make sure that you could see it is because this is kind of the basis for what we do. We start to work with equations. And so because that's the basis, our whole first section of Delta Math work that we're going to be doing for your homework assignments this week is completely, can you evaluate an expression? And I think they're a little bit complicated, but they're not terribly so. It's just, can you plug something in and get an answer? Now, what I want to show you really quickly, we're going to do a second example here. And when we do, a lot of times when we do a second example, it's something where we're going to try a whole new set of things. Now, for me, what I want you to do for a minute is we're going to use the exact same expression that we had before. But instead, what I'm going to be plugging in is x equals, let's say, 2. The reason I want to do this is because I want you to think for a second about how these things work differently. I know what the answer is, Uzziah, but thank you for writing it up there. Okay, so when I'm looking at this here, we're still finding a different answer for this. So I know that I'm not going to get out of 49 because I'm not plugging in the same answer. If I'm using the same expression with a different x value, we will get, it's okay, Uzziah, we will get out different answers. And that's kind of what helps us in terms of how we think about solving equations. And that's kind of the part about this that I want us to look at. So when we look at this here, if I'm going to simplify this, or if I'm going to evaluate this, the process is the same. I'm going to be taking that instead of x, I'm going to be replacing it with that 2. So the rest of the stuff is the same around there. I plug that 2 in, and now my process is literally exactly the same as what I did before. It's just instead of doing -4, I'm going to be doing this with 2. So, okay, y'all help me out. What is 2 to the second power? What does that equal? Yep, 4 is correct. So this is 3 times 4 plus 1. What is 3 times 4? That is indeed right, 12. And if I do 12 plus 1, that will give me at the end of this the answer 13. So we have 2 different answers to the same expression. It just depends on what you evaluated it for. What was the x value that we plugged in to get us these different answers? Now, one of the problems I run into when I create examples is not that I create bad ones. These are actually pretty good examples to go through. The problem is that when we solve equations, throwing in things like x squared, it's fine, but it's not going to be as easy to solve. And so what I want to try to do first is to let me give you a simpler one that we're going to do kind of the same thing with. And so down here at the bottom, I did this sort of line. Let me just put this line in the middle here. Let me give you here. This will be an easier one. We'll go example 3 here, and I'm going to give you 4x plus 5. We're going to be evaluating that for x equals -4. And so let's see what we can get. And then I have another space on here so we can kind of fill through this. So with this one, what is my first step of this going to look like? If I'm going to evaluate this, which is what we asked for, what do I got to do? You can't say the answer yet. You got to tell me what I got to do to put it in there. What am I replacing? What am I doing? How does this work? Somebody type it. Yep, I replaced the x with -4, and that 4 times -4 in parentheses is what I was looking for. I always use parentheses, and you guys should too, because it means we're not just going to be put them next to each other and thinking about it as like a subtraction. It means I have to multiply the 2 of them. So if I replace that x with the -4, now I'm doing the work. So here, what is 4 times -4, everybody? What does that give you? -16. And that -16 plus 5 will give me a final answer of -11. So when I get the -4 into this one, I get a -11. I didn't have to raise it into the second power, so this one becomes a little bit more simple. And then if I take, for my last example for doing these, let's take the exact same expression and let's plug in something different. Let's see this one for x equals 2 and go through the same process. Now, this comes to be the point in time where it's a Monday. And what I recognize is that I too am being bored with writing all of the same crap in here all at the same time. But I bet you could tell me, what do I put in the set of parentheses and do it kind of quick? What goes in here? What do I put in there? Yep, 2 is correct. And so I'm doing the math. 4 times 2 is 8. And 8 plus 5 is going to give you, 13. So here's the part about this that I want to make sure you guys understand, because I'm going to, I think, use the examples that we just did to show you how some of this stuff works differently. So the points that I want you to pull from this for a minute is, even if you have the same expression, depending on the x value that you have, you can get different results. So -4 gave me -11, +2 gave me +13. And the x values themselves, having them be different is important, but if we look at our original problems that we had up here with the 3x squared, it doesn't always mean if I plug in -4, I'm going to get out the answer of -11, because this one was 49 and this was -11. Sometimes it's the same. When I plugged in 2 here, I got out 13, and the same thing here, but it doesn't always work that way. the what is in the expression is extraordinarily important, so that when we think about the rules that are being followed, that's what we do to the value x to make something like this work. So when I look at this, it shouldn't be too terrible to see what we're doing. And this is kind of a review. What we're going to start to do is the part about this that I don't want you to be confused about. I more want you to be interested in sort of the way that this works. And that's when we bring in the idea of an equation. So this is sort of new material, but I am going to ask this. If anybody here has seen equations before, type yes in the chat if you've seen equations. Okay. Enough people have said yes that I feel pretty good about this. So let's talk for a second about what these actually are. First off, the thing about this that's going to be important, and honestly, what makes it an equation more than anything else is an equal sign. And I put parentheses around it so you just kind of see that like this is contained there. But like if it's got an equal sign and there's stuff on both sides of that equal sign, it's an equation. And as I said before, I'm going to bring back the other notes. We had equations here. We had x equals -4. That is an equation. But we used that in a little bit of a different way. We used this because it told you what to plug in here, and we went through to find it. What you're going to get with problems here today is you're going to get something that's going to look a little bit different. Like here'll be an example of what I can write. If I give you 4x plus 5 equals -11, the equations we're going to be working with essentially work this way. 4x plus 5, we actually used that expression not too long ago. This is an expression. And essentially, when we're talking about equations, the way that they're set up is that you'll have an expression on one side, and it's going to equal some expression on the other side. Now, most of the time when we start this off, it's an expression that has a variable in it on one side, and normally there's a number on the other side of the equation. But most of these things function in such a way that it's like an expression equals something else. So in this case, an expression equals a number. Now, it's what that equal sign is that sort of helps us working here, because what's being asked here is a lot different than the sorts of problems when we were doing evaluate. With an evaluate, it was, I told you what x is, I told you the expression, I want you to tell me the answer when we use that value. And so for here, what's actually happening when you have an equation that has a variable in it is that they're asking the question, for what x value will this expression equal -11? It's asking, what does x got to be to make this true? And so I don't tend to write lots of words in my notes, but the reason I like writing this one in here is because I think having this question helps you conceptualize what it is that we're doing when we solve all of this crap. Because what starts to happen with these is that you guys will go in and it's going to be like, okay, what do we do? What do we do? Well, we have to do this. We got to do this. It's about what do we do to solve this equation as opposed to how does this work? And that's where I want us to start today. So here, the questions actually being asked is, for what x value does 4x plus 5 equal 11? Question mark. It's asking, what is that x that makes this true? Now, here's the thing that's great about the way that I set up these examples. We know that answer. We know for what x value 4x plus 5 equals 11, because see, we did that here. I already know this -11 that I'm trying to get to as the answer is what we got when we plugged in -4. So if that's the case, first off, let's put the negative here so I'm not screwing that up. But since I already know what that's going to be, the answer to this question is that x equals -4. And we know that because we did all that work from before. And that's the part about this that's kind of important, is that what we're trying to think about when they ask the question, for what x value does 4x plus 5 equal -11, what we're really trying to find out is, what can I replace that with to make this true? And that's the place where I kind of want to make sure that we have it written the right way. Because I think what tends to happen and what we tend to miss when we're doing all of this, we miss the point of what you're doing when you're solving equations. And a lot of times what the point is that you're looking for something that makes this true. So I'm going to put this off on the side. It seems kind of deep. So, Lean into the deepness. You are seeking the truth. Put a little exclamation mark. That's what all of solving equations are. We are seeking the truth. For what x value does 4x plus 5 equal 11? X equals 4 is what makes this true. Any other number, if I plug it in there, is not going to equal negative 11, so it's not true. And that's kind of the place where we're talking about this. Now, let me do something for just a second. I want to go back and give you another one. This is something an adventurer would say. I am a mathematical adventurer, and I'm more than happy to take you on this adventure with me. Seems kind of creepy, but that's okay. Here's what we're going to do. I'm going to write you another example here. And what I want you to do for just a second is I want you to think, could you tell me if I gave you the equation 3x squared plus 1 equals 13? First off, what question is being asked here? What is the question that I need to answer to seek the truth? What is x? Now, that is a good question, but is that really the question that's being asked with this equation? It's not just what is x. There's more to it, because I asked what is x here, but I didn't ask what is x exactly. There's more to it. What would the question be? Hold on. I have to stop. Somebody's phone calling me during my, oh, there we go. Legit. CJ, good job. For what x does, I'll just say this expression, equal 13, question mark. It's the whole thing put together. It's not just what's x. Because the problem is that when you ask the question, what's x, there's like a million different ways you can get to that. There's a million different values of x. And so the problem is that if you don't specify what the question is, sometimes it's hard to figure out what you're trying to get to when you're seeking the truth, like the mathematical adventurers that you are. When we see this, I need to know what x does this expression equal 13. Now, guys, do you remember what the answer to this is? Because we have, in fact, done this problem not too terribly long ago. Do you guys recall for what x value 3x squared plus 1 equals 13? You could look back if you took notes. If you didn't, that's fine. I would totally get it. Do you guys remember what we had for that? Jamaiah, you're right. Isaiah, you're right. It is when x equals 2. If you guys look, we did that work right here. We plugged in 2 to get the answer. Now, here is something that I want to talk to you about for a second. If you've had a math teacher in the past that gives you a problem like this, most of the time what they start to get into the mood of at the very beginning is, okay, so what I want you to do first is to look and see where the x is. And what we got to do is undo all of the work around the x to be able to get to what we're supposed to do. So the first thing that we need to do is to get rid of the 1. So we do that by subtracting 1. And then we're going to so that voice is the voice that happens in my head every time something like this happens. Right now, since we're just looking for the value that makes this true, here's a place that you can start with if you don't have an answer already. We already did this. We plugged in 2, we got out 13, we know the answer. So what I would do, if you're not sure of what that answer is, don't go through this and think about it in the, what are the steps that I have to do to cancel everything out? Just for a second, for what we're going to be doing for this week, try to see if you can do this by a little bit of guessing and checking. And this is what I mean. We know we're looking for x values. So if I'm going to go through and do a little bit of work, I'm just going to put some stuff here and say, why don't we try a few first and see what happens? So if I'm going to try something, let's say an easy place to start is 1. If I want to try 1, let's see what happens. So if I plugged a 1 in there, let's see what we get. Because sometimes the answers to things that are wrong gives us direction as to the way we can figure out what is right to get to those things for truth. So I plug this in. 1 squared is 1, and I'll just do this work below it. This is the same as 3 times 1 plus 1. And then if I do the math of the multiplication first, 3 times 1 is 3, and there's still that plus 1, and 3 plus 1 is 4. Now, that did not give me the answer I wanted. I wanted 13. When I plugged in 1, I got out 4. So for what x does this expression equal 13? Well, no, we know it's not 1, but I want you to use that and think for a second. I plugged in a 1 and I got out a 4. So should my x be larger or smaller than 1 if I want to get to 13? That's my question. Should my x be larger or smaller than 1 if I got out of 1, if I got out of 4 and I want to get to a 13? Do I need a bigger x or a smaller x? Somebody should type this in the chat, because if you don't, I'm just not moving forward. I'll just keep talking. Do I need a bigger number or a smaller number if I got out of 4 instead of a 13? Yeah, I need a bigger number. That's right. And the way I look at it is, I think about it, if a smaller number gave me a smaller number, then I can get a bigger number. Now, we know the answers too, but I want to show you something really quickly. What if instead I wanted to plug in x equals 3 because I wanted to try even more? And I go through the work and I say, okay, it's the same thing, but when I'm doing it, I plug in the 3 instead. Now, I think about this. 3 squared, 3 to the second power, that's my first step. That is equal to 9. So this is 3 times 9 plus 1. 3 times 9 is 27. 27 plus 1 is going to give me 28. Too big. So you're kind of honing in on what answer it's going to be. And in this case, we already know, we did it in the first page. We know x equals 2 is going to be our golden child here. So as we go through and do it, it's going to give us 3 times what number squared? So 3 times 2 squared plus 1. That's going to be 3 times 4 plus 1, which is 12 plus 1, or 13. We have found the truth, and that's the place that we're trying to get to when we do this stuff. As long as we've got an answer, we've gone through and figured it out, we're in good shape. We had already done this work, though, so it wasn't that difficult to get to. I just wanted to show you how we sort of guess and check to get to the place of saying, if we don't know, what gets us to that truth. And so I think the last thing that I want to kind of leave you with today is the idea to what we're actually doing when we're finding our x values. What you're trying to find is a solution. And so when I talk about a solution to an equation is the x value, and it could be any variable, but I'm going to say x value because that's what we do most of the time, that makes the equation true. And so when I say that you are looking for the solution, it doesn't mean I'm going to cancel all of these things out and get x by itself. That's the process that some of you may have learned before. The solution itself is what is the value that makes it true. So if you choose to go that route to find it, that's great. If you choose to guess and check, that's fine too. What we're talking about now, if I'm looking for a solution, is just what x value will make this equal to whatever their result is, okay? So that's how we're going to be going through and thinking about this for at least this week. When we start to go through the process, that's going to be something that comes in next week and we'll build on over the course of the semester. But if you think about this first, that's going to be the thing that gets us to what is it that means that this is true or not. And that's kind of where I wanted us to be. So with that being said, I'm going to say your homework assignment is to make sure that you go in and you do the Delta math problems that are there. And they're all sitting up there waiting, and I'm sure that I made it so that it's going to drop. So again, if you're not sure how to get to Delta math, that's something you can find in your classroom all the way up at the top where it has the class info. It's a place that you can go in and go to the link and get there. All of you guys, I think, have logins. But what I really want to make sure that we're able to get to when we look at this is the idea of knowing we're trying to get solutions, okay? And that's kind of the point. Now, I'm going to stop sharing right now, bring us back to this, and I'm also going to stop recording because I don't think there's anything new that I'm going to give.